Alright, hello everybody and welcome back. So today we're going to be talking about properties of real numbers and use of exponents. And we're going to be talking about, the first thing we're going to be talking about is a closure property of addition and multiplication. So for the closure property of addition, if a and b are real numbers, then a plus b is a unique number. So basically what that means, okay, so say a equals 3 and b equals 10, a plus b is equal to 13. It's going to produce a completely different number than the two numbers that you had for the variables. Okay, so now for multiplication, it's the same thing. So say a equals 3 and b equals 10. AB is going to be equal to 30, which is completely different than the values of A and B. Alright, so now let's move on to the commutative property. So for addition, it's A plus B equals B plus A. And for multiplication, it's AB equals BA. So a quick reminder, this property, the commutative property, it just doesn't work for subtraction. So a minus b is not equal to b minus a. I can give you a quick example for that. So let's say a equals 3 and b equals 5. So then you have 3 minus 5, which is equal to negative 2, and then 5 minus 3, which is equal to positive 2. So negative 2 is not equal to positive 2. Therefore, the subtraction for the commutative property is not, it just doesn't work. So our next property is the associative property. And so for addition, we have a plus b, and then that's in parentheses, plus c is equal to a plus parentheses b plus c. So notice how it went from a plus b in the parentheses to b plus c. And that's basically what the associative property is that you can move. So if if these variables are in parentheses, you can shift it over or move it so that it becomes this. There's another thing you could do. You could do b plus parentheses a plus c. That would also work in the associative property. So now for multiplication, it's the same thing, except you multiply. You have ab parentheses times c equals a parentheses bc equals b parentheses ac. So that is also true. Now we're going to talk about the identity property. The identity property is basically, for addition, it's what number can you add and make it result into the same number that you had. So say I had 18, then what number can I add to this 18 so that it remains 18? And that would be 0. So then you can see that for the addition part, a plus 0 equals 0 plus a equals a. Now for the multiplication, it's the same thing. What number can I multiply with 18 to get 18? And that would be 1. So in the multiplication property, in the identity property of multiplication, you get a times 1 equals 1a is equal to a. So now we're going to be talking about the additive inverse property of the additive inverse property. It's only for addition. So the additive inverse property is basically saying what number can I add to this number so that it results in 0. And basically what you have to do is take the negative of your number that you have here and then you get 18 minus 18 is equal to 0. So then you're basically doing negative x. I mean, assuming that the 18 is equal to x, you would do negative x, which is what the additive inverse property is. A plus parentheses negative a equals negative a plus a equals 0. So now we're going to be talking about the multiplication property of 0. And this one is essentially the same thing as the additive inverse property, but we just have to do what number can we multiply to a number to make the product 0. And that would be 0. So now we're going to move on to the multiplication property of a negative 1. And that is saying that a times negative 1 equals negative 1 times a is equal to negative a. Alright, so now we're going to move on to the multiplicative inverse property, which is saying that a times 1 over a is equal to 1 over a times a is equal to 1. Okay, so now we're on the distributive property, and that is saying that a times b plus c is equal to ab plus ac. So what you're doing is you're multiplying it with that, and you're multiplying it with that. That's pretty much it. And then you just keep the addition sign where it is. It's right there. Okay, I just can't draw an arrow right now. So let's move on to our first example. We have 74 plus minus 36 plus 36. So we know that 36 minus 36 is equal to 0, right? So now let's apply one of the properties that we know, the associative property, and shift these parentheses over to include the positive 36 so that we can get 0. So we're going to have 74 plus brackets, parentheses, negative 36, parentheses, plus 36 brackets. And then you're going to get 74 plus 0, and that's equal to 74. There you go. Next example. So we have negative 19 times 25, and then end brackets, times minus 4. So we know that 25 times negative 4 is equal to 100, and that will make our multiplication a lot easier for us. True, we could do it like this, like how it is, but it's going to be a lot more complicated than if we just use the associative property and shift it over. So we're going to have negative 19 brackets 25 times negative 4 end brackets. And that'll give you negative 19 times negative 100, which is going to give you negative, or no, not negative. Remember that negative times negative is equal to positive. And then I explained that in my last video. So there's going to be an info card at the top right. Go ahead and check it out. And that's equal to 1900. And that's the answer. So now let's move on to example number 3. So we have 25 times negative 2 plus 100. Now we're going to use a distributive property. And we're going to do negative 25 times 2, and then negative 25 times 100. So negative 25 times 2 plus negative 25 times... Oh, I messed that up. Okay, so negative 25 times 100. And then so negative times positive makes it negative. Oh, wait, no. The 2 is a negative number, so I forgot to include that. And then there we go. Okay, so negative times negative is a positive, which brings you to 50, plus negative times positive, which is negative, and you get negative 2500. And then when you add that up, you get negative 2450 as your answer. Our next example. So we're basically going to use the distributive property, except we're going to undo the distributive property. So remember that it's A times B plus C and A times B plus A times C. And in this, our A is 3.7, our B is 104, and our C is negative 4. So let's solve it. So we have 3.7 times 104 minus 4. And we can see that 104 minus 4 is equal to 100. So 3.7 times 100. And now we know that the answer will be 370. The reason why I know this is because whenever you times anything by 10, 100, 1,000, and so on, the amount of zeros that you have shift the decimal places however many zeros there are. So say you're multiplying with 1,000. So you would move it 3 decimal places to the right. So 1. So 1, 2, and then 3. So your new decimal would be over here, and then you would just add 2 zeros to fill the places. That way you will get 3,700. So in this case, we have 3.7 times 100. So then you would do 1 and 2, since there are 2 zeros here. And then you would put the 0 as the placeholder. So then you would get 370. Okay, so now we're going to be talking about exponents. So the exponents are exponents are basically like n. So this n right here, that's an exponent. So what an exponent does is that you have to multiply the number that many times by itself. So in this case, we have b to the power of n. So that would be b times b times b times b times b, and so on. Depends on how many times n asks. So n factors of b. Okay? So n has to be a positive integer and b has to be any real number. The reason why I say positive integer is that we haven't learned about what happens when n is negative. So we will learn that later. And just for now, n has to be positive. So just keep in mind that negative a to the n is different than parentheses negative a to the n. So negative a to the n means that you will do the negative later. Like, what I'm saying is that if it's negative 3 squared, you will do negative 3 times 3, which will equal to negative 9. But if you have parentheses negative a to the n, then you get negative 3 times negative 3. So if there's parentheses, you're including the negative. If there's no parentheses, you are not including the negative when you're multiplying. Okay, so our next example. 3 times negative 4 squared plus 5 times negative 3 squared. Remember that these both have parentheses around them, so we're including the negative. So negative 4 squared is equal to negative 4 times negative 4, which is equal to 16, because positive times positive, or not times negative times negative is equal to a positive. And then negative 3 times negative 3. So, dang it. Okay. So, negative 3 squared is equal to negative 3 times negative 3, which is equal to 9. because positive times negative times negative is equal to positive. So, and then since we know those two are 16 and 9 respectively, we get 3 times 16 plus 5 times 9, and then we simplify. So 3 times 16 is equal to 48 plus 45, and that is equal to 93. Alright, let's move on to our next example. So in this one, we have to use PEMDAS. PEMDAS is very important in order of operations, and right now that's what we're working on. Excuse me. So we have parentheses this time. These are the parentheses. We actually have multiple. So right there, right there, right there, right there. Okay? And then we also have exponents as well. Right there. That's your exponent. We do have multiplication, both here and here. And then we have subtraction as well. Okay, so now let's solve it. Hopefully it doesn't look like a mess. So, parentheses. We can't really solve anything in the parentheses, so... Oh, actually we can. Right. Alright, so we have brackets. 3 times negative 1 is negative 3 minus 2 times 1 is 2, close brackets. Put the cube back down here. And then you do brackets, negative 5, brackets, cubed. So since it includes the parentheses slash brackets, we have to include the negative, which means you're getting negative 5 times negative 5 times negative 5. And then, so you have, what's it called? Negative times negative, which is a positive, but a positive times a negative, which is a negative. So that is negative 125. And that is my last example, everybody. So I hope you learned a lot from today's video. The next video is going to be about section 1.4, algebraic expressions. If you liked it, go ahead and hit the like button. If you want to get notified for when my next video drops, you make sure to hit the subscribe button and hit the bell icon too. Thank you for watching, everybody. I hope you stay safe during these times.